Here's an overview for how I make 3D printed rudders, or more specifically how I assemble them. I'll make them as two halves with um, the rudder post, or I don't know, piece of metal in the middle, sandwiched there. I'll end up looking something like this. So what I do in the 3D model is I'll leave a groove for where the post will be, and then I'll just take, in this case, stainless steel 1/8 inch. I also use brass a lot of times, but brass isn't quite as strong. So I'll take this, then I'll use 2 pairs of vice grips to bend it to shape, like this, or like you see here. And then once I have the post set up, I'll rough up these surfaces with the sandpaper and the Dremel, and then I will just epoxy them together. Just put epoxy in the middle and then clamp it. So this shows how I set up the vice grips. I'll leave a little gap there, which will allow them to rotate against each other, and then I'll just grab this one, bend it until the jaws hit each other, and then I'll kind of readjust and then bend it to the final shape. And I'll use just the rudder as the guide for how far it needs to go. Here are all the rudders epoxied together. Just coat both sides. I put wax paper down and then use the 2 clamps. The post and the groove for it keeps the pieces lined up. The rudders are dry. There's some excess epoxy that I will clean up with the Dremel, and then I'll also clean up the shafts with some sandpaper to remove any epoxy that got on there and make sure they fit through the tubes at the rudder post. So the rudders are cleaned up. So now I need to cut off the excess part of the post. So what I'll do is, you can see there I just used a Sharpie to mark the bottom, and then I'll just use my gear, which is 3/8 inch. You can see the hole there at the bottom. So I'll just add 3/8 inch from that mark, and then cut them off, and then put a flat spot for the set screw and the rudder gear to go into. Here's the finished product. So cut down, and then the flat spot. I usually try to make the flat spot directly in line with the rudder. To figure out where you want to do that, you want to consider what angle you'll be able to get the set screw to be in contact with the rudder. So now that these are done, I'll put them in, and then I'll check for contact with the propeller, just by kind of holding the rudder at different angles and rotating the prop. Usually on this style, because it has the lip at the top, the kind of upper corners are usually the most common area for contact. But it looks like these are all clear. So now I can install a set of rudders that I can use for sea trials. I have one set of the rudders installed. See them there. One thing I like to do on my gears is I'll use a Sharpie to mark where the set screw hole is, because that helps find it with the Allen key. And then one thing which is more of a design consideration is making sure you'll have access to the set screw holes and figuring out how that's going to work. I mean, at this point it's a little late since the design's fixed, but when you're planning, you want to think about that. And then once you get them installed, you want to kind of rotate them around, make sure they're free to move They're not gonna get hung up on anything, like on the bottom or, um, you know, on another obstruction. Here are different rudders I've used for various ships on the past. On the top, these are all made out of wood, so you can still make various shapes with wood. So I talked about the area, which is basically like length and height, and then there's also a width restriction, so total width needs to be no greater than 7/8 of an inch, or if you have two rudders, then that combine with sort of the same restriction. The wooden ones, I won't show a demo of building one, but I'll just sort of talk about it because it's a good deal more work. In terms of rudder shape, with the width, a lot of people will put what we'd call like plates or like a curved surface on the edges to help catch more water. This is a printed rudder, but you can sort of see the same thing, some sort of concave profile on the flat surface relative to like a real rudder on a ship will have more of a airfoil shape, but real ships are usually more concerned about drag than we are on battleships where drag is actually a good thing. So to make one out of wood, I would use like 1/8 inch ply as a core. You can kind of see the sort of I-beam shape. The post will have a bend in it to make sure it doesn't, the rudder and the post don't break apart from each other. And then for these curved surfaces, I'd put balsa wood in there, which is easier to sand. But the tops and the end would be plywood. So, you can still, if you don't have a printer, you don't know anyone has a printer, you can still make one out of wood, just a bit more work. In terms of shapes themselves, a lot of people just do a basic rectangle, and this works in a lot of cases. For the Sodak, and then other boats that have a slope in their stern area, you can go with that, or a step. So this is an old one off Agincourt. These rudders right here are for multi-rudder ships, so they're skinnier and they're smaller relatively. So different shapes that are common. You can have a rectangle, typically, especially if you have 3 props, 2 rudders, we'll end up with a more vertical rectangle. This is for Scharnhorst. And the shape I use most often now has this like semicircle profile. So I can show it on Missouri here. If you think about it, it maximizes the area in the middle of the where the prop is. So from the prop, just think about like a cone of thrust sort of coming off from that prop. So this will hit the cover as much of that cone as possible. And then this is also a possible shape that people use where it's a similar idea as the semicircle, but you're putting more of your area up here. But in side-by-side comparison testing, I've had the best results with this semicircle. It can be it's certainly harder to calculate the area of this, but if you're savvy with math, you can set up a spreadsheet to calculate exactly the right size. Okay, I also talked about a linkage. So this is one of my old linkages from my very first boat. So this arm right here, this would go on the rudder shaft, and this linkage would go to the servo horn, and then you can sort of see it would be like a push-pull. And these work, some people use them, but gears or sprockets are better, in my opinion.